This video summarizes the Math 1 lesson titled Greater Than. This is a develop understanding task. The purpose of this lesson is for students to reason with inequalities and their properties. For each question in this task, decide which of the two expressions is greater, if the expressions are equal, or if the relationship cannot be determined from the statement. Then we need to write an equation or inequality that shows your answer and explain why your answer is correct. So statement 2x minus 3 is greater than 7. So which is greater, 5 or x? Well, if I substitute 5 in for x, 2 times 5 minus 3, I get 7. And is 7 greater than 7? No, 7 is not greater than 7. That's not a true statement. So whatever x is has to actually be bigger for you to have a number bigger than 7 on the left side of this inequality. So like 8. 2 times 8 is 16. 16 minus 3 would be 13. 13 is bigger than 7. Another way to look at this is you could just solve the inequality. So 2x minus 3 is greater than 7. To solve an inequality, very similar to solving an equation. So I'll start by adding 3. This is a property of inequality. It doesn't change the value of each side of the inequality as long as I add the same number to each side. All right, now I'll divide with the division property of inequality, and I'll get that x has to be greater than 5. For number 6, which is greater? So my statement is x is greater than y, which is greater, x plus a or y plus a. So if I have x is greater than y, if I add a to both sides of my inequality, then x plus a has to be greater because x started off as being greater. To further explain why that works, let's think about a number line. If x is greater, it means that it is to the right of y. The bigger numbers on a number line are more towards the right, and the smaller numbers are more towards the left. It doesn't matter where 0 is on this. If x is greater, it's always going to be to the right. So if I add a, that means I'm adding some amount of a. Let's say it's this distance. So that puts x plus a right here. And then if I add that same a, now I have y plus a right there, assuming that this a and this a are actually the same length. So x plus a, still bigger than y plus a. This actually helps us understand a property of inequality. It helps us understand the addition property of an inequality, because if you add the same value of a to both x and y, it does not change the symbol. X plus a is greater than y plus a because x was greater than y. Let's take a look at number 7. It's the same type of problem except we have subtraction. So it's the same type of answer except we'll just have the subtraction. We know that x minus a is still going to be greater than y minus a because both sides are being decreased by the same amount. Again, if we look at our number line, if x is greater than y, if we subtract, we go this way to subtract a from both of these values, x minus a is still going to be greater than y minus a. This is the subtraction property of inequality. Whenever you're subtracting the same value on either side of the inequality symbol, then the inequality symbol doesn't change. All right, for number 8, the statement is 5 is greater than 4. So which is greater, 5 times x or 4 times x? We don't really know what x is, so it's hard to answer that question. Let's think about this. If x is a positive number, like 2, right, then I have 5 times 2 would be 10, and that is greater than 8, 4 times 2. However, what if x equaled a negative 2? So I have 5 times negative 2 gives me negative 10, and 4 times negative 2 gives me negative 8. Well, now negative 8 is actually the larger value. If we think about this on the number line, when I multiply by 2, so I double 4 to get to 8, and I double the 5 to get to 10. You still had 5 is bigger than 4 and 10 is bigger than 8. However, when I multiply by a negative, what that does is it makes the number an opposite. So 8 is now a negative 8 and 10 is now negative 10. So here the order changed because of the opposite. So the sign flipped. Whenever you are multiplying by a negative number, the sign will need to flip, which is the multiplication property of inequality. When you multiply both sides of the inequality by a positive value, your sign will stay the same. However, if you multiply both sides of the inequality by a negative value, then the signs will flip, which means it'll change from greater than to less than, or if it started off as less than, it would change to greater than. All right, and the same thing happens with number 9. So which is greater, 5 divided by x or 4 divided by x, when you have 5 is greater than 4. So whenever you have a positive value, so we can do a positive value, we'll just do 1 this time. So if x were to equal 1, then you would have 5 is greater than 4. When you substitute it into 5 over 1 would be greater than 4 over 1. However, if x is a negative 1, you'd have 5 divided by negative 1, which would give you negative 5, and you'd have 4 divided by negative 1, which would give you negative 4. Now negative 4 is actually greater than negative 5. So this is the division property of inequality. When you divide by a positive value on both sides of the inequality, your inequality sign will stay the same. However, if you divide both sides of the inequality by a negative value, then your sign will flip. So in this lesson, we've looked at several properties of inequality. The addition property of inequality and the subtraction property of inequality are very straightforward. Essentially, you can add or subtract the same value on either side of the inequality, and the inequality sign will stay the same. For multiplication and division, if you have a positive value that you are multiplying to both sides of the inequality, then the sign will stay the same. However, if you have a negative value, in other words, c is less than 0, meaning negative values, then your sign will flip. It'll go from less than to greater than, or from greater than to less than. And of course, these properties would also work the same way if you had less than or equal to or greater than or equal to for any of these problems. All right, that's it for this video. Thank you for watching.